Hey everyone, welcome back to the Foundations in Pre-Calculus 10 videos. In this video, we're going to look at Lesson 6 from Chapter 6, which is talking about the general form of the equation for a linear relation. So up to this point in our chapter, we've looked at two different types of equations to represent a linear relation. The first one being your slope-intercept form, and the second being your slope-point form. So now we're going to look at the last two forms, which is your standard form and your general form. So here if we were to consider the equation 2x minus 3y is equal to 12, this here is written in standard form, and it has the following general form, where you have a number connected with your x value, plus a number connected with your y value, and it's equal to some sort of number. So really important here is that a, b, and c, they're just numbers. Okay, so don't be overwhelmed when you're seeing 1,000 or, like quite a huge number of variables compared to what you're used to. But A, B, and C, they're just numbers. Like in our equation here, we have 2, -3, and 12. So those just represent numbers. And so this is what we call in standard form. So the next one we're going to talk about is when we have general form. And this is almost identical to standard form. But one exception here is that our C is going to be on the left side with the rest of our variables. So here we would have ax plus by plus c is equal to 0. So what's really important here is that our c value is moved to the left side, and then so what is happening here is that our equation is equal to 0. Okay, so that is your general form. So standard form and general form are almost identical, but standard form has a number that your equation is equal to, while your general form, all of your numbers are pushed to one side, and so that equation should be equal to 0. So we're going to look at example number 2 from your notes. We're going to be looking at finding some values given that equation and then graphing that equation. So here we have an equation x plus 3y plus 9 is equal to 0. So just to clarify here, here we have an equation where we have a number not connected with a variable on the left side, and the right side here is equal to 0. So this one here is an equation in general form. So part A here asks us to determine the x and y intercepts. So we'll start with finding our x-intercept first, and this here is where we let y equal to 0 in our equation. So here we have x plus 3 times y, which is 0, plus 9 is equal to 0. So 3 times 0 is just 0, and 0 plus 9 is just 9. We can then move this plus 9 over to the other side by subtracting, so doing that opposite operation. So then we have our x-intercept is equal to -9. From this, we could create a coordinate if we would like to. So here our x-coordinate was -9, and that y-coordinate we let be 0. So we would have the coordinate -9 and 0. If you left it as x is equal to -9, this would be fine. But I'm going to put this into a coordinate, which will help us out for part B. So now we're going to find our y-intercept. And so this here is where it crosses your y-axis. And at this point is where we let x equal to 0. So when you're finding those intercepts, you let the opposite variable equal to 0. So in our equation, we're going to substitute x with 0. So we have 0 plus 3y plus 9 is equal to 0. 0 plus 9 is just +9. Then we can move 9 over to the other side by subtracting. So we have 3y is equal to -9. And then we want to get y by itself. So this here is multiplying 3. So we're going to divide by 3 on each side. So here we have y is equal to -3. And from that we come with our coordinate of x is equal to 0 and y is equal to -3. So that's part A. Here we had to find those x and y intercepts. So you have to let that opposite variable be 0 and then just put that into your equation and solve for that variable that you're looking for. So here we're going to graph the line of the equation that we just looked at. And so normally what you would do is you would normally create a table of values, but one thing that we've already done is that we've already found 2 points on that graph. So from that, we actually have enough information to graph. One little caution I might hint that you guys should do on, say, your homework and your assignments is that you might want to do do a table of values for another point. That way you can have 3 points, because really important is that you want 3 points to make sure that you don't have any math errors or any calculator errors. So if all 3 points line up on a straight line, then you know you've most likely done something right. But in this case here, I'm going to be okay with just graphing our x and y intercepts. And those of you, if you want to just be a little bit more cautious, I would recommend making a table of values for that 3rd point. Alright, so here we're going to be working with the coordinates. We have -9 and 0, and we have 0 and -3. So our first step when we're graphing is that we need to label our x and y axis. So when we're looking at our x values, here we have to make sure we can fit -9 and 0 on that graph. So if you were to count out each of the lines going left and to the right, you notice that there's 10 lines on either side. So what we could do is go up by 1 square is equal to 1 value, and then I'm just going to label every second one just so I don't have a very cluttered spacing here. Then just very careful, make sure that each graph or each little square represents the exact same number. So now we need to look at our spacing for our y-axis. So here we need to fit 0 and -3 on our y-axis. So one thing just to remember here is that we don't have to choose the exact same spacing for our x and y-axis. It's just that our spacing going up and down, each square must represent the exact same number. So that'll be very important. So if you guys were to count the lines, you'd see that we'd have 10 lines going up, 10 going down. And so just as my general rule of thumb, just remember, I usually like to use a good chunk of my graph. So depending on how you want your spacing, I would accept either going up by every square represents 1, so using the same x-axis, or same as our x-axis, or you could also do that every second space equals 1 value, so then your highest value will go up to 5. So in either one of those cases, I would totally accept that, but just make sure that in other cases, we would want to see our graph in a pretty good spot and see a good chunk of what's going on. So we typically like to keep it in this little range here. We don't want to see a little corner of it over here or over here. That's not ideal. We can't really see what's going on. So I'd be very, very okay with you guys either going up by 1 square is 1 or every 2 squares is 1. And in this case here, I'll just decide to choose the same spacing as our x-axis. So every line equals 1, and I'm going to label every second one, so every 2 lines is 2. So I'm going to go ahead and graph those 2 points. So here I have -9 and 0. So I'm going to go to x is equal to -9 and y is equal to 0. Then my other point is 0 and -3, so I'm at x is equal to 0 down to y is equal to -3. So now what I'm going to do is I'm going to connect my 2 points and make sure that on your notes and on your assignments and homeworks, make sure you guys connect your points using a ruler. That's very important, or it does not represent a straight line. So make sure you guys use a ruler. I am very particular about that. So here what I'm going to do is I'm going to pull out, I've got Microsoft Tools here to just draw a nice arrow here connecting my 2 points. So mine can actually look straight as just as yours should. And so here I'll also change up the color just because that's a little bit harder to see. So I'm going to change this up to red. And so that's kind of what our graph there should look like. So one thing that's really important here is that we're going to have arrows on each end of your graph just to make sure that we show that our line keeps going on and on forever. Just because we chose to find the x and y intercepts doesn't mean that that's where the graph stops. So make sure you put arrows on the ends of each of your graphs and that you have a nice straight line using that awesome ruler. So as I said, you guys can choose a minimum of 2 points. I would like 3, just to make sure that I'm on the safe side. Which at that point you might want to consider choosing a value in between your two coordinates here. So if you're between -9 and 0, you might have maybe want to choose maybe x equals to -4, -5, and then just so you can get yourself a third value so it looks a little bit nicer. And that way you're a little bit more confident that you've done the work properly in part A and even in part B. But that is everything here for this video. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.